Let's now solve a couple of application problems that involve linear systems. So this first one, Marla buys 5 bags of frozen corn and 3 bags of frozen beans for $15.62. Sam buys 3 of the same bags of corn and 4 of the same bags of beans for $13.53. How much does each bag of corn cost, and how much does each bag of beans cost? Set up and solve a system of equations. Be sure to define your variables. So for any of you that might feel a little overwhelmed when you come across an application problem, the key thing to doing any application problem, whether it's a system or not, is you have to do this part, and this is the part that students often skip. We need to define variables to let them represent what it is we're looking for. So it says, how much does each bag of corn cost? Well, let's let a variable represent that cost that we don't know. So you can choose what you want when you write it down as well. It doesn't have to be X and Y. In this case, I'm going to use C for corn. So let C be cost of 1 bag of corn, because it says how much does each bag of corn cost? That's the cost of 1 bag. And then the other piece of information we want is how much does each bag of beans cost? So, I don't know, let's let B be the cost of 1 bag of beans. This is an absolutely essential step because now you have objects, precisely C and B, that you can build off of. Right? So now each one of these sentences up there creates an equation. Let's go through this one first. So Marla buys 5 bags of frozen corn and 3 bags of frozen beans for $15.62. So if she buys 5 bags of frozen corn and each bag costs C dollars, then the total amount of the corn would be 5C. And then she's also, so adding on, buying 3 bags of frozen beans. If each bag of beans cost B, then 3 of them would be 3B. And then that total cost is equal to $15.62. Do the same here now with this sentence. Sam buys 3 of the same bags of corn and 4 of the same bags of beans for $13.53. So 3 of the same bags of corn, the cost of that would be 3C, plus 4 of the same bags of beans, the cost of those would be 4B, and the total cost is $13.53. We now have created a system of linear equations. So this part is the application part, defining your variables and then translating the sentences into these equations. Now from here, this should just be purely computational. We need to solve this system of linear equations. And again, don't forget we have 3 techniques. You can use graphing, substitution, or elimination. Unless you already have a graph presented to you or you're told to use a graph, I wouldn't go that approach. Instead, let's do it either via substitution or elimination. With this one, since none of the B's or C's have coefficients of 1, I'm going to go ahead and use the elimination method. So what can we multiply the top equation and the bottom equation by, each 2 different numbers, to eliminate perhaps, let's say, the C's? Remember, we need opposite coefficients on either the C's or the B's. Well, if you multiply the top equation by -3, that would end up giving you a -15C here. And if we multiplied the bottom equation by 5, then when you distribute this 5 in here, you'd have a +15C. So we'd have opposite coefficients on the C's, so when you add the equations, the C term would fall out. So let's rewrite this new system now with the -3 multiplied into the top and the 5 multiplied into the bottom. Don't forget to multiply both sides of the equation by these. So -3 times 5C is -15C, and -3 times 3B is -9B, equals 1562 times -3 is -46.86. And then we multiply the 5 into the bottom equation. 5 times the 3C is 15C. 5 times the 4B is 20B. And 5 times 1353 is $67.65. So now we've got opposite coefficients on the C's, so we now want to add the 2 equations, and the C variable will fall out. So we've got -15C plus 15C is 0C. 0 times C is 0, so we're not going to add on 0, so I'm not even going to write that. -9B plus 20B is 11B. And negative 46.86 plus 67.65 is 20.79. Now to complete this, we need to divide both sides by 11. 20.79 divided by 11 is 1.89. So B is 1.89. Don't forget, we also need the value of C, so we're not done yet. We need to take this B and plug it into one of the original equations to solve for C. So we've got 5C plus 3 times, in place of B, I've got 1.89 equals 15.62. So let's solve this equation for C. So we've got 5C plus 3 times 1.89 is 5.67 equals 15.62. And to solve this equation from here, we need to subtract 5.67 from both sides. We get 5C equals 14.95. And we need to divide both sides by 5, which would give us C equals 2.99. Now we have the value of B is 1.89, the value of C is 2.99. When we're solving these in the abstract, meaning it's not an application problem, we usually write an ordered pair. But anytime you're doing an application problem, we want to just simply say in words what each of these means. So B was the cost of one bag of beans, and we just got 1.89 for that. So that means it costs $1.89 per bag of beans. And we just saw that C, which is the cost of one bag of corn, is $2.99. So we've got $1.89 per bag of beans and $2.99 per bag of corn. Let's now look at another example.